Alright, in this section here we're going to be talking about operations with radical expressions. So we've been working with radicals, but now we're going to be working with some operations, and that means we're going to be adding, subtracting, and multiplying these expressions. Okay, so we always start with a fairly easy example. If I had 3 square roots of 5 minus 5 square roots of 5, and of course what we're doing here is we're just simplifying this stuff down, and 8 square roots of 5, and we wanted to simplify this completely down. Well, you notice we have a square root of 5 in each one of these terms here, so that means that you could factor out a square root of 5 if you want and do it that way, but since they're all alike, what we can do is just add their coefficients. Alright, so 3 minus 5 minus 8 is going to be negative 10. Then you just write square roots of 5. Alright, square root of 5. Okay, 3 minus 5 is negative 2, and negative 2 minus 8 is negative 10. Alright, let's look at another one here. If I had 6 times 3 roots of 10 minus 11 times 3 roots of 10. So as you can see, we have 3 roots of 10 in both of these. So this would be 6 minus 11, and 6 minus 11 is going to be negative 5. I'll write it right here. And we just write 3 roots of 10. Rewrite that part there. Okay. So this time we'll do one that's a little bit more difficult. 5 times the square root of 12 minus 2 times the square root of 27 and plus 3 times the square root of 3. So this time what we're going to need to do is break this up. We can simplify this down. So this is the square root of 4 times 3 minus, and this is the square root of 9 times 3, and of course we can't break that down anymore. So this can be broken down as 5 times the square root of 4 times the square root of 3. We can break that up, minus 2 times the square root of 9 times the square root of 3 plus 3 times the square root of 3. Now, the square root of 4 is 2, and 2 times 5 is 10. Square roots of 3 minus, and that's going to be the square root of 9 is 3. 2 times 3 is 6. Square roots of 3 plus 3 square roots of 3. Okay, well, we broke those down. Now we just add their coefficients. So we have 10 minus 6 is going to be 4, and 4 plus 3 is 7. So this is all equal to 7 times the square root of 3. Alright, what about if I had 4 roots of 32? Well, we could write this as 2 to the 4th times 2, and I'm going to write this now in exponential form. So now you would just multiply exponents. 4 times 1/4 is 1, so that would just be left with 2, and then we couldn't do anything else with this 2 here. Getting it back into radical form. 2 times 4 roots of 2. So that would be the final on that. Alright, now let's work some with, it's got a variable involved. Alright, let's say we had 27 x minus 2 times the square root of 12x plus 2 times the square root of 48x. We're going to simplify this down. So what I'm going to do is I'm going to break this 27 up. We know that 27 is 9 times 3. And we know that 12 is 4 times 3. And 48, let me do a little side work over here. 48 is equal to 6 times 8. Okay, we know that off the top of our head, but this can be broken down to 2 times 3, and then that can be broken down to 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Sorry, too many 2's there. Okay, so we know we have 1, 2, 3, 4 2's. We've got 4 2's and 1 3. So I'm going to write 2 to the 4th here, and then a 3, and then of course we don't want to forget our x. Well, we know that the square root of 9 is 3. So I'm going to write it like this. You know, we could break this up as the square root of 9 times the square root of 3x, and then we take the square root of 9 as 3. Okay. Minus, now the square root of 4 is 2, and 2 times 2 is 4. Hope you're following me on that. I'm hoping I can get away with skipping some steps. We have this 2. I better not skip this step. The square root of 2 to the 4th. Well, remember, we can write 2 to the 4th all raised to the half power. Instead of writing the radical, write it in exponential form, and a half times 4 is 2. So this would be 2 squared, which is 4. So this ends up being 4 times 2, which is 8. Yeah, we're just going to put 8 here. And then times the square root of 3x. Okay. And I'll just rewrite all this. Okay, we just add coefficients now. -1 plus 7 is, or 8 is 7. So all that reduced down to 7 times the square root of 3x. Okay. Good enough. What do we got going on next? You know what? I think I'm going to go ahead and just clear the board. 4 roots of 162 times x plus 4 roots of 32x. So we need to break this 162 down, and what you should start with is how many times does 2 go into that? Well, we know that 2 times 81, right, is going to be 162. I should probably put it in exponential form. We'll break this down. This is 8 times 4. But we can break this down. This is 9 times 9. I'm going to start writing this in the exponential form here. Alright, plus, oh, and this, alright, we want to, I'm going to write, let's see, this is 4 times 8. This, I guess I'm just going to write it like this. This is 2. We're going to go ahead and break this down. 2 times 2 and then this 8 right here is going to be 2 times 2 times 2. So you know the biggest part, whoops, yeah, well, I needed to put an x here also. And it's all raised to the 4th power. The biggest part of this stuff is just factoring these things, breaking these things down. And of course, this 81, which was the 9 times 9, can actually be written, 9 is 3 times 3, and this 9 is 3 times 3. So you'd have 4 3's, so 2 times 3 to the 4th. Plus, now we're going to take 4 of these 2's and we'll have to leave one of them here. So this is going to be 2 to the 4th times 2 times x. And the reason we're doing 4 here is because we've got our exponent is it's all raised to the 1/4 power, and we know that when we multiply 1/4 times 4 we're going to get 1. Alright, so let's do that. 3/4, you know, I guess there's no sense in skipping steps at this point. Sometimes that's the reason we don't understand math, is because too many steps have been skipped. Need to add the plus sign there. And a lot of students, that's usually their biggest complaint. So now we have 3 to the 4th, and it's all raised to the 1/4, so you can multiply, so you're going to be left with 3. Now I'm going to go ahead and make that jump and get everything back in radical form. Okay, and so this becomes plus 2 times 4 roots of 2 to the x. And now what we can do is go ahead, and since both these are the same now, we can add their coefficients. And so this becomes 5 times 4 roots of 2x, and that's as far as we can go. So the big part of this is, you know, factoring the 162 and the 32. Yeah, that's usually the struggle. Alright. 1 over the square root of 2 plus 5 times the square root of 2. So to get this radical out of the denominator, you multiply the bottom by the square root of 2 and the top by the square root of 2. And that's going to be the square root of 2 over square root of 2 times square root of 2 is just 2 plus 5 square roots of 2. So what we have now is we have a half plus 5. In other words, if I were to factor out that square root of 2, we'd be left with a half plus 5. So now we're down to solving a fraction here. So that's 10, 11. And of course I write that 11 on this side over 2. Right, 11 times square root of 2 over 2. And alright. We'll work one that's got a variable here. Plus 5 square roots of 2x. Alright, so I'm going to rewrite this part here as the square root of x over the square root of 2 plus, and then we'll just keep that the same. There's nothing we can do with that. Now to get this radical out of the denominator, I multiply the bottom by the square root of 2, and of course the top we have to do the same thing, and we're going to be rewriting the rest. So the square root of 2 times square root of 2 is just 2. So we end up with the square root of x times the square root of 2 over 2. Now, since both of these are square roots, the square root, I can go ahead and join those, and we're going to write it like this right here. Now we have two terms that are like, and so we could look at it like this. Where I just factored out a square root of 2, and so now we're left with what's a half plus 5. Well, that's going to be 11 square roots of 2x over 2. Alright, so we want to isolate this radical. So I'm going to rewrite this piece here as the square root of 3 over the square root of y minus the square root of y over the square root of 3, and there's nothing we can do with that. So to get the radical out of the denominator, we write the square root of y over, so we did square root of y over square root of y. Okay, if you've been keeping up, then that shouldn't be foreign. So to get rid of the square root of 3, we go square root of 3 over square root of 3, and then I just rewrite this part here. Okay. So this becomes, I'm going to go ahead and join this together. So hopefully at this point, right, you'll know what I'm doing. Square root of y times square root of y is just y minus the square root of 3y over 3 minus the square root of 3y. Now I can go ahead and factor out the square root of 3y since it occurs in all of our terms. So this becomes 1 over y minus 1/3 minus 1. And then of course you can join all this together in one single fraction. But I'm just going to leave it like that. So, but you can go ahead and join this up if you want. But we're going to end it there. If you forgot how to do that, right? Get a common denominator, which is going to be 3 over 3 minus y over 3y, then minus 3y over 3y, and so we have 3 minus y minus 3y, it's all over 3y, and so that becomes 3 minus 4y over 3y. I said I wasn't going to work this out, but I guess it looks like I am. 3 minus 4y over 3y. Okay, there you go. Hopefully I didn't make any quick mistakes there. I don't think I did. Alright, looks good. Okay, well that ends this, and that ends the problems in this section. Alright, well this is kind of part 2, because we've talked about the operations with radical expressions in the previous section, but this one here we're going to kind of focus on multiplying radical expressions. And of course we always want to start with something simple, and that is we're going to start with the square root of 3 times 2 plus the square root of 5. And what I'm going to do here is expand this. I'm going to distribute this square root of 3 across each one of those terms. So we have square root of 3 times 2. Wow, I said 2 and wrote a 3. Let's get rid of that real quick. Cut that out of there. And times that by 2. Okay. Plus, and then we have the square root of 3 times the square root of 5. Okay. Now I can rewrite this. I'm going to take this 2 and bring it over here in front of the radical. Plus, and I can join both of those underneath one radical. So that'd be 3 times 5 is 15. Alright. So let's look at another one. I don't know, we'll just write it down here. What if I had the square root of x times 3 plus the square root of x? And what I'm going to do is multiply this across again. So this time I'm just going to write the 3 on this side. Alright, and then square root of x times square root of x. Square root of x times the square root of x. So we can kind of simplify this down a little bit. Now, a square root of x times square root of x, if I write that under, that's x times x is x squared. But that will reduce down to 3 times the square root of x. Now remember, if I was to write this back into going from radical back into exponential, remember what we do with the exponents, we multiply them. And so we would have 3 times the square root of x plus, and 2 times a half is just 1, so we would just be left with x. Okay. Let's go ahead and clear the whiteboard on that. And let's look at another one here. What about if I had, not to forget that, if I had 2 times the square root of x minus 1 and 3 times the square root of x plus 4, and we want to multiply these together. So it'd be 2 times square root of x times 3 times the square root of x. So that'd be 2 times 3 is 6. And we would have the square root of x times the square root of x, and then 2 times square root of x times 4 there, so that becomes 8 square roots of x, and then negative 1 times 3 square roots of x, so that becomes negative 3 square roots of x, and then negative 1 times 4 is negative 4. And of course, now remember we said the square root of x times square root of x was the square root of x squared, but then, right, we're just left with an x. So I write 6x, 8 minus 3, these are like terms, 8 minus 3 is 5, square roots of x minus 4. Okay, so that's pretty much, after multiplying that out and simplifying it down, this is what we're left with. Okay, let's look at this one here. Let's say that we had forgotten to add the layer again. Alright, let's say that I've got the square root of x minus the square root of 3x minus 2, and the whole thing is squared. And we want to multiply all that out. So we're going to have to rewrite. I'll rewrite it down here. The square root of x minus the square root of 3x minus 2. Now because there's 2 of them, right, we're going to write it all out. Minus the square root of 3x minus 2. Okay, now we're going to multiply this stuff out. So the square root of x times the square root of x is just x, okay? So you should have caught on to that in the last couple problems. The square root of x, this is going to be minus the square root of x. Of course, we'll write this out, won't skip any steps here. 3x minus 2, and then the square root of 3x minus 2 times the square root of x. And of course, I'll keep it in the same order. And then of course, then we have plus, because we're going to have a minus times a minus. And the square root of 3x minus 2 times the square root of 3x minus 2 is just 3x minus 2. You know, the square root goes away. Now we want to simplify this. So we have two of the same terms here. And I'm going to write it like this. So 3x minus 2, and then we have plus 3x minus 2, and now what we're going to do is collect up some like terms, so these two are like. So that becomes 4x minus. Now I can go ahead and bring this x inside, so I've got one radical here. 3x minus 2. And then we have minus 2 out here. Don't forget the minus 2. And you can distribute that x inside if you want. But I'm going to leave it right like that. So hopefully you were able to keep up with all that. I'm trying to go as slow as I can. Alright, well, you know, that's just multiplying some rational functions, rational expressions. Let's look at fractions, rationalizing the denominator, because this is something that is always asked to do, and that's to rationalize the denominator. If I had 1 over the square root of 3, now I think we've done this before, but I may have not have said rationalizing the denominator, and I want to get rid of the radical down here in the bottom. Well, we'd say the square root of 3 over the square root of 3, and 1 times the square root of 3 is the square root of 3, and the square root of 3 times the square root of 3 is just 3. So that's rationalizing the denominator. But let's say that we had something like 1 over the square root of 3 plus 2. Okay, the trick we're going to use here is we're going to multiply the bottom by the square root of 3 minus 2. So you see this, we have the square root of 3 minus 2 over the square root of 3 minus 2, which this is just 1. Okay. So now we've got 1 times the square root of 3 minus 2, so I'm just going to write that like there. And then we multiply the denominator. So square root of 3 times square root of 3 is 3. Square root of 3 minus, that would be 2 times the square root of 3. That's supposed to be a 3. And then plus 2 times the square root of 3, and then 2 times be negative 4. Now of course we want to clean this up. This is the square root of 3 minus 2, and it's all over 3 minus 4 is a negative 1. Those cancel out, and so we can say, and of course we wouldn't write it like that, we would just say this. I start getting in a hurry, and I start getting sloppy. So let me write a little neater down here. Okay, so this all canceled out, and then we had 3 minus 4, which was negative 1, but I brought the negative up top. So this is what we got to be careful about when it comes to these negatives. Alright, if I get rid of this fraction right here, and I still have a negative, we got to consider this piece here to be in parentheses. So that's what you got to be careful about. So if I were to rewrite this, we have to distribute this negative inside. So this becomes a negative square root of 3 plus 2. Or we could rewrite this as 2 minus the square root of 3, which would be probably the more proper way to do that. So be careful about these negatives here. Alright. Okay. Let's work some more of those. I've got plenty of examples. Let's say we had the square root of x plus 5 over the square root of x minus 4. The idea here is we want to get the square roots out of the denominator. Alright, and we do that by multiplying the bottom by the square root of x plus 4 and the top by the square root of x plus 4. Okay, and I guess we should put parentheses around this here. Alright, so we multiply this out. I'll just go ahead and multiply the numerator first. So square root of x times the square root of x, remember it's just x. The square root of x times 4 is going to be 4 times the square root of x, and then 5 times the square root of x, plus 5 times the square root of x, and then 5 times 4 is 20. And that's going to be all over. So we do the bottom. Square root of x times the square root of x is just x. The square root of x times 4 is 4 times the square root of x, and then we have minus 4 times the square root of x, right? Negative 4 times the square root of x, and then negative 4 times positive 4 is negative 16. So now we need to simplify this down, collect up some like terms. We have an x. Looking at the numerator, these two here are like terms, so 4 plus 5 is 9. Square root of x, and then plus 20. And that's as far as we can go on that. And of course, those guys are going to cancel out. You know, that's the whole idea. The reason if I have a minus here, I'm going to put a plus here. You know, that's the whole idea there. And so we're left with x minus 16, so we got the radical out of the denominator. The radical out of the denominator. Alright, let's work another one here. We're going to learn about that. Alright, 1 over 3 roots of x plus 3 roots of y. So we just do the same thing here. We multiply you know, this is a little trickier here because I just seen something. Let me rewrite this out as 1 over let's get this to x to the write it in exponential form here, and this is y to the 1/3. Now remember, we multiplied this guy by something over here. We got to get rid of this exponent. We need it to be a 1. Okay, so that's what we got to look at, and plus the sign here is going to be opposite. So in other words, 1/3 plus what is equal to 1, and what we're looking at, a is going to be 2/3. Alright, a is 2/3. Alright, I was going to work this problem here, 1 over 3 roots of x plus 3 roots of y, but I'm going to leave that as an exercise. And instead, I've got a much better one here, 1 over the square root of 4 minus the square root of 2 minus the square root of 3. We want to get rid of these radicals in the denominator, and this is how we're going to do it. I'm going to rewrite this as 1 over. Now the square root of 4 is just 2. Okay, I'm going to factor out this negative here, and that's going to leave me with the square root of 2 plus the square root of 3. If I were to multiply this back inside, we would end up with this here, right? Now what I'm going to do is I'm going to multiply the denominator by the square root, or not square root, 2, the plus, and this is going to be the square root of 2 minus the square root of 3. Alright, and then of course we want to write that up here in the numerator also. Square root of 2 minus the square root of 3. So we have 1 times this up here, so I'm just going to rewrite this. This is 2 plus the square root of 2 minus the square root of 3. Now when we look at the denominator here, we multiply this out. 2 times 2 is 4. 2 times this stuff here in parentheses, square root of 2 minus 3, and then you would have 2 times this, and of course the inside terms cancel out. Okay, and so we'd be left with minus the square root of 2 plus the square root of 3 times the square root of 2 minus the square root of 3. So as you can see, this was the reason why we started with a plus sign here, and that was the reason I put a minus in right here. Okay. Now of course we multiply this out, we're going to have 2 plus, of course I'm just now rewriting the denominator here, so I mean the numerator, not the denominator. 4 minus, start a big parenthesis, square root of 2 times square root of 2 is 2. Square root of 2 times negative square root of 3, and then square root of 3 times square root of 2. Those will cancel out, and so we left with square root of 3 times square root of 3, but it's going to be a minus 3. Alright, so I'm going to rewrite 2 plus the square root of 2 minus the square root of 3, and 2 minus 3 is going to be negative 1, but then we're going to have 4 minus a negative 1, so that's going to leave us with, right, 4 minus a negative 1 is 5. So it leaves us with a 5 in the denominator. So it all reduced down to, believe it or not, this guy right here. So that was a tricky one there. Tricky, tricky, tricky. And I think that's going to be enough examples on this part 2 part of these operations on radicals with radical expressions. Or, I don't know, what did I name this section? Operations, yeah, with radical expressions. So we went through them: addition, multiplication, and then, of course, in a rational form. All right.